Good morning, good afternoon, good evening, wherever you might be, and welcome to my post on breathing soap bubbles. This one's going to be more sciencey. Panspermia is a funny idea. Free-thinking Fred Hoyle was convinced that the molecular statistics, which would lead to the spontaneous development of life on our planet, were not in line with the age of the planet. He believed that it would simply take too much time for all of the random combinations to occur for the formation of a DNA molecule and a cell. Instead of life spontaneously emerging from a primordial soup, he suggested that the universe was teeming with DNA-like molecules carried around on comets that shoot around the cosmos, fertilizing planets. Thank you for that, Professor Hoyle. I love what you did with nucleosynthesis and the steady-state universe, but I think the emergence of life can be explained without interstellar sperm. At the birth of DNA, picture an electrically conducting filament floating in water. Dielectric, less conducting molecules get stuck to this filament so that it forms a coaxial cable with water as shielding. In a religious sense, this is the moment of, in the beginning, there was the Word. A photon hits an unshielded part of the filament, let there be light, causing current to flow up and down the length of it, forming a standing wave with a helical form. The standing wave acts as a substrate on which molecules formed the helix, which we know as RNA. If you stick some RNA together, you get DNA. It would make sense that the DNA strands, which tend to survive, occur within protected spaces, like bubbles, which shield them from disturbances that would cause them to break up into randomness. The simplest form of a bubble is a micelle, the smallest possible bubble. It has fats on the inside and phosphate on the outside, and if something hits that bubble, giving it energy and causing it to blow up, you can end up with larger bubbles with a lipid bilayer, as in a cell, a bacteria cell, for example. But bubbles tend to pop when they get too big. It is only with additional energy that they can survive with a larger size. So to support the existence of a larger bubble, there needs to be an energy pump or proton pump, which feeds the release of energy within the cell. I think of it as a balloon that needs to be blown up again and again to keep it from collapsing. In this story, a bacteria cell is born through a symbiotic relationship between a bubble, which is trying to survive, and a string of DNA, which is trying to survive. Perhaps the term trying to survive sounds stupid to you. A soap bubble is not conscious in the sense that we think of for ourselves. But if you use a materialist definition of consciousness, it makes more sense. I think of the DNA as being parasitic to the bubble. When the DNA replicates itself, the bubble has to work harder to maintain its integrity, and it eventually splits in two. But why would DNA replicate? I think of it as a trash disposal system within the cell. As the cell ages, a bunch of molecules that don't contribute to its survival build up inside, and these molecules are made up of the raw materials that make DNA. When the area around a strand of DNA gets dirty enough, the strand breaks apart in two, and all of the dirt sticks to the open ends of the strand. The end result is 2 identical strands of DNA. Now the cell is big and fat with too much DNA in it, and the membrane surrounding it divides so that the energy needs of the cell can be served more efficiently. So far, the DNA doesn't need to have any special code in order to support this form of life. It could be totally random at this stage. It is only through competition between different types of DNA-filled bubbles that certain patterns within DNA would become dominant. Modern bacteria have only 4 million base pairs, and only 1% of those pairs encode usable information. So the number of combinations is not as astronomical as Fred Hoyle estimated. Then there is the magical moment when a smaller bubble gets inside of a larger bubble, releasing its contents into the larger bubble. The DNA in both the large and small bubbles will have a higher likelihood of surviving and replicating if the strands combine in such a way that the bubble evolves. Any DNA that doesn't evolve won't survive. If only one type of bubble existed, it would be easier to destroy them with a single attack method. But when there is a variety of types of bubbles with different properties, they will act in different ways, making it harder to pop all of them with a single technique. This creates the conditions for an ecosystem of bubbles to evolve and for complex patterns within DNA to develop. In terms of physics, you have a negative entropy system. The energy produced within the cell stimulates the replication of components with preferred length scales. I'm pretty sure that I learned this story from books I read when I was a child in the 1980s, but in a recently published pop science book called The Vital Question by Nick Lane, this line of thinking was not described at all. He portrayed the biology of cell creation as completely unknown and mysterious. So it was confusing for me to see that the story I was told as a child seems to have been forgotten on the level of the media and in terms of what's being taught today. So that's why I'm making these videos. I have a pretty good memory of my classroom experience from the pre-internet age, and I'm surprised to find that a lot of what is taught on the internet is very different from that, in that old narratives are simply being forgotten because they were part of an oral tradition in the classroom, not the textbook tradition, they're similar, but there are little stories that were always told to students that made things make more sense intuitively that weren't in the textbooks, and those are the stories that I really liked, and I want to give them to you. In other popular science media, I found an expression of surprise that microbes which breathe in and out produce more energy and reproduce more than microbes that are frozen and unable to breathe. Here you see an action, breathing, which evolved to help a microbe survive. Breathing bubbles can be seen as the basis for many other physical systems, and that's why it doesn't surprise me to see this in biological systems. For example, gravity between planets can be described in the same way as the attraction between soap bubbles in a vibrating liquid. One can picture the suns and planets breathing in and out and thereby radiating their gravitational potential energy wells. General relativity is just the static approximation of this dynamic process, which was first described in the 1700s by Laplace. Another soap bubble-inspired example is the life cycle of a star, a system that plays out like the formation, expansion, and popping of a bubble. In more detail, the story of a star is the story of the journey of a particle from the outer edges of a cloud of gas into the center and back again. It involves distributions of particles which are chirped and bunched across various cross-sections. Those are technical terms for having a continuous spectrum of frequencies, a linear, or it could be a nonlinear. These bunched particle groupings are under the influence of a self-generated field, which causes them to accelerate and radiate energy coherently to create the breathing of the sphere, which gives rise to gravity. That energy acts back on the particles and increases their correlated energy spread. At a certain point, maximum bunching and correlated energy spreads are achieved over large length scales, and the corresponding collective motion leads to an unstable density in the center of the star, which causes the star to collapse like a bubble, leaving behind a glob of matter, with a large uncorrelated energy spread and residual bunching factor at a harmonic of the resonant bunching factor of the red giant. So, why would anyone care about such a crazy story? Well, there's a star called Betelgeuse, which is a red giant, and people are studying how it pulsates and produces light to try and figure out when it's going to pop. I doubt that this free electron laser physics-inspired story that I just told has been told in detail, but I bet it would be a good one. To tell it properly, one would need some good simulations using a free electron laser code adapted to a radial coordinate system. The jumping off point for this picture was in a post I made on Quora. So I encourage you to take a look at my blog, and it has links to all kinds of supplementary content for these stories. One can likewise describe the electron degeneracy pressure, or the attraction between electrons, and an atomic nucleus in terms of bubbles. Like gravitation, electromagnetic attraction is just an inverse squared law, derived from simple geometric considerations related to the ratio between surfaces and volumes. People today speak of the vacuum as nothingness, which contains fluctuating energy density in the same way that a swimming pool contains water which has been stirred up and then left to oscillate randomly. Fundamental particles are like vortices swirling around bubbles in such a swimming pool, and they can pop into existence by borrowing energy from the ambient fluctuations, sort of like a tornado springing from a wall cloud. Something I understand intuitively because I grew up in a place called Tornado Alley and spent a lot of time during my childhood studying clouds and trying to determine whether or not it's a wall cloud or not. When the particles are moving around in, say, a swimming pool of space, their interaction distance changes in proportion to how fast they are moving. This is just the lesson of relativity. To a stationary observer, the space between particles acts like it changes when the particles move faster, and how a quantum background fluctuation looks to us will depend on how fast we are moving relative to it. Notice that I emphasize the words acts like and looks like because Of course, the distance between the particles didn't actually change. They only act like the distance changes. It's an important thing to understand. This distinction connects relativity to quantum mechanics, allowing one to think about ideas like, is the cosmic microwave background the quantum vacuum written large across the night sky as a consequence of our motion relative to another reference frame? When you break this down into simple geometry, space is nothingness filled with time, which flows in straight lines and in circles which rotate at a rate which depends on how fast they are moving in a line. The time it takes for one revolution to occur is like the tick of a clock. What I'm trying to illustrate is a picture of a spectrum of physical systems, suns, planets, cells, particles, which can all be described through the physics of soap bubbles. Before concluding, I'd like to take a look at the science of soap and how it is taught in typical classrooms today. Soap is an emulsifier, something that encourages the suspension of one liquid in another. Soap helps water break up globs of oil. Water does this already. If you shake a jar of water and oil, the oil droplets will break up into smaller droplets in an emulsion. Soap just helps the water make these oil droplets even smaller. In simpler words, soap makes water wetter. But what is wetness? Wetness describes how quickly and easily a liquid can flow into a crack in something. If there is a crack in an oil droplet, soap helps water get in there. But how? Soap must change something about how the water molecules are arranged. Strangely enough, water molecules in liquid form arrange themselves in long chains and rings, and a long chain has a harder time breaking into a crack in an oil droplet than a short chain. It's bigger. Soap helps break up the hydrogen bonds within chains of water molecules so that they are smaller and able to break up oil droplets into smaller pieces. Now, this is the story that seems consistent with the academic research on soap, but it's completely inconsistent with the way I see the science of soap taught in the popular science media and in YouTube videos. And I'm sure this has influenced bad teaching about soap in classrooms across the world. So, for example, I have linked to a YouTube video in which soap is described in terms of micelles, little tiny soap bubbles, traveling around and collecting dirt in their centers like little dirt capturers that eat dirt. And this doesn't make sense because just because fat could potentially get stuck in the middle of one of these micelles doesn't mean that is the mechanism by which soap cleans things. According to what I've learned, soap micelles break up chains and loops of water molecules, changing the properties of the water so that it breaks up oil more easily. That's a completely different mechanism than little micelles that go around eating dirt. But after seeing how awful YouTube videos on special relativity, for example, in terms of trains and tunnels. I mean, those are terrible. The video on soap makes me worry that the internet is causing terrible teaching to spread like wildfire, because there are a lot of stories that seem like they make sense, seems like it should be like that, it could be like that, but it doesn't acknowledge that there are alternative parallel stories that have actually been tested that are correct and they're different. So you might ask, why do I think I'm the authority? Where did I learn my soap makes water wetter story? Well, I didn't learn it from the internet. I learned it back in the 1980s from the adult daughter of an old chemist who had spent his career studying soap, chemistry, for a big company in the United States that I can't remember the name of. It was one of the companies that makes detergent. My guess is that the answers in terms of dirt-eating micelles were spread like via the internet. That's all I can conclude. In any case, after reading an academic thesis on the simulation of micelle formation, little soap bubble formation, I've learned that it is a mistake to believe that micelles form via nucleation around a hydrophobic particle like oil, meaning this particular thesis says that the conventional wisdom about micelles eating dirt is wrong. This particular thesis found that micelles form via replication following the application of energy. So pressure, for example, where they grow from a minimum size and then split after reaching a maximum size. This makes sense. A bubble blows up and then it pops and splits. This mechanism suggests that oil would only inhibit the formation of micelles because it would cause the soap molecules to stick to the sides of an oil droplet and do nothing, not go around and clean things. I think this fits better with my picture than with the YouTube picture, and that filtering the signal out from the noise on the internet is becoming increasingly challenging. In this post, I have connected together several fields of inquiry to show how many systems can be described by a single basic breathing soap bubble principle. From time to time, it is important to remind ourselves that when the Tower of Babel gets too high, everyone starts speaking their own private, specialized language and forgetting that the similarities they have in common. Extending into the metaphorical realm, books are very much like bubbles, which protect the ideas within them. And I've written 4 works of fiction to protect some of the ideas that I find important. And I'm working on finishing 2 works of nonfiction. So I encourage you to check out my blog and click on links there to see my books, and they might just be your thing. They might be something you like. Thank you for watching, and please tune in for more of my videos.